When we introduce people to active winglets, we'll often get questions about the safety of including a load alleviation system on an aircraft. Everything from reliability questions to wondering what happens if the active camber surfaces deploy asymmetrically. Not many people realize that load alleviation systems have been around since the 70s. Aerospace engineers and certifying authorities have already worked out how we can design, analyze, and test systems like our Atlas. Regulations for certifying a load alleviation system are relatively well established, especially under European regulations, which are accepted in the FAA regulatory environment as well. We can start with the reliability. If you're depending on a load alleviation system to keep your loads in check, you want some confidence that it's reliable. And if it breaks down, you want to know about it right away. It's the law that load alleviation systems have annunciation to the crew for all failures that could significantly impact the structural capability of the airplane. And it's even mandated that the annunciation be designed to fail no more than one time in a billion flight hours. We also look at the worst case loads on the aircraft for various failure scenarios. This includes failures where the system is just inoperative, if there are failures that send the active camber surfaces to symmetric deployments either upward or downward, oscillation failures, and of course, the asymmetric failures. We look at the loads for all of these failures both at the time of occurrence and for the remainder of the flight, so that we can ensure that the failures won't overstress the structure. We also look at the longer-term impact of these loads from a metal durability standpoint, and we evaluate the elastic properties of the structure to ensure that these failures won't produce a flutter event. At a more practical level, we also use special test equipment to flight test the various failure modes in flight characteristics. These include flights where we purposely deploy the active camber surfaces asymmetrically to ensure that the ailerons can counteract and the aircraft can be trimmed. We approach this a lot like certification of an autopilot that may have failures that the crew would need to counteract. As you can see, there's a lot of work that goes into ensuring that the load alleviation system is safe. But the rules are well established, and aviation has a history of safe operation using load alleviation.